Here in project management, here we have an electrical cam table. We click new to build one and name it. And in this page, we can see the self-axis offset, self-axis speed, and self-axis acceleration. And in the program, we need to use one output in terminal to simulate the input. So I connect Y1 to X0. So when this instruction running, X0 will received plus contently. So the HSC 0 will keep increasing, and this is used to simulate our master axis. As I said, our master axis is always keep just like it's always keep in a content speed. So I used a content plus to simulate our main axis. And now what we draw is the plus of the slave axis, this part. So we need to know when we need to send plus to, and when don't need to send plus. For example, yes. Here in data settings, we have these parameters. First line, we don't need to change it. We start setting and first line. Here we first set the master axis. The unit is plus. For example, here I set 1000, and then here self axis plus. If I set 500, and here we also need to set the cam curve. Here we have three types. Here I use constant speed, and it means when the master axis running 1000 plus, our self axis will run 500 plus. We can draw to see. Here we can see when our master axis run here 1000. This is unit 1000, and our self axis will move to 500 plus. And then the speed, here we use constant speed, so we can see the self axis speed is constant and 0.5. If here we use the content ACC, the moving will just like this. It will acceleration first, and then keep the speed. This is the speed changing. It will increasing, and reduce to 0, increasing from 0 to about 1, and reduce to 0. And this is our self-axis acceleration. We can see if we set constant ACC, our self-axis acceleration will keep constants. It will keep on to first, and then change to this. So this is the different cam curve. But we can see the result is the same. The result is when the master axis ran 1000 plus, our self-axis will run 500 plus. It will no change. Okay, this is our first sector. In our first sector, we can set another, for example. And also this resolution, this number is total to a max to 511. Each part end up to 511. If here I set 500 and here I set 100, it's add up to 600. It will have error. The bigger this member, the more this member means how many points to make up this curve. If here I set 500, means this curve is made up by 500 points. I set 100, and the second sector also I set 100, and they won't use constant speed. Now we click drawing. Okay, now we can see when the second sector means when the master axis ran to 2000 plus, our self axis will run 400 above 4000 plus. Here in the curve we can see when the master ran 1000, our self axis will run 500 here. 500. And then the second sector. When our master went to 2000, this is unit 1000, and our safe axis will run to 4000 here. Here we can see it is 4000. Okay, and now let's set two sectors. Okay, here we need to note it is the master axis plus master be greater and greater. We can't set here, for example, here we can't set the number smaller than 2000. If we set 1500, here we also will have a error. Incomplete setting in 3 section. Because I said our master axis is always running, so his path will also increase all the time. 3000, and here I said 0. We can see when the master ran from 2000 plus to 3000 plus, from 2000 to 3000 plus, our safe axis will run from 4000 plus to 0. Means our safe axis returned to origin point. This is how to draw the cam curve with our software, and now I will show how this curve works in the program. Here, connect to our PLC and download our PLC program. Here remember to select this one, electrical cam table. This table is this one we just created. Wait a moment. master plus. This is our master plus, and this one is our slave plus. Compile all. And now I click start. Save. And then this is the speed. The speed of our master axis. I set it to smaller, 100. Here we can see when our master plus increasing, our slave plus will also increase. And when the master plus increasing to 2000, our slave plus will increase to 4000. And at last, our master plus will output max up to about 3000 plus, and our slave plus will return to 0. Let's see it again. Okay, at this point, when master plus is 1000, our slave plus is 500. Also here we can change our curve. 8 1000. Remember the resolution add up to not expand 511. Okay, and now this is our new curve. The master plus will range from 0 to 5000, and the slave axis will increasing from 0 to 100, and from 100 to here, and also, and at last it will return to 0, just like our table, parameters table. Now we need to download this curve to our PLC again. Here we need to download it again because we changed the curve. Here we can see the changing of our master plus and slave plus. Our slave plus will change depend on this curve. And so in the application we will use this. Oh, sorry. Here we need to change because here our master plus is changed to 5000, so here we need to change to 5000. It means when the master learned 5000 plus, this program will stop this instruction. We just I just show you just one cycle. Yes. Now click start. Yes. Oh, sorry. Let me clean the plus first. And now see. When the master ran to 1000, save plus will also to 1000, and reduce, and increase again. Reduce again. And the last it will return to 0. So if in a machine you may see it run from here to here, and here to here, and here, and last return to his first place. It will. This is the active. This is the real application. Okay, and this is the. Also here we used a DCAM instruction. About this instruction, you can see our manuals. Our manual have already introduced all the parameters how to set. Here I set at least 2. This one means our program will perform just one cycle. And the first one here, okay, I will introduce easily. This is the first parameter. The first parameter is the input plus. Is our master axis, and then the second is our ECAM parameter table. The first address, the 1000, and then below we may need to configure 1001 and 1002, 1003, and so on, just like these two, 1005 and 1003. The third parameter is used to start the ECAM. We only close here is not enough. We also need to close this one to start the ECAM to run. And this is the output in terminal, and this is the Y0 is our output in terminal, and Y4 is our direction output. This is our plus output. This is our direction output. Okay, and this is how to use curve, ECAM curve to how to use software to build ECAM curve. And now I will show you how to use the move instruction to draw cam curves. ECAM curves. Yes, you are right. This is our master master axis. Now in this program, this is our program. How to write, how to use demove instruction to draw our ECM curve. This setting is the same as last program. We just end this part. Here we use demove to our our DCAM instruction. ECM table function address is from D1000, and so here 1080 and 3T8 is our is this selection numbers. How many selection we need to set. Here in program we set 3. Okay, wait a moment, I will show you. Yes, this one. This is the parameters I introduced just now. We have more detail introduced in our manual. Here in program, I set the start address is D1000. So here this is D1000, and now we look at 1038. You can see this is the number of segments in the table. Here I set 3, and then 1040. This is 40 and 41 is the is our first master class. This one. This parameter. Our first one 0, segment 0. We need to set it as 0. Don't change it. Just like our ECM table. This line, the 0 line, we can't set it. We set from the first line, first selection. So here, in 1044, I set to 2000. 1044 is this parameter. Spaniel position of segment 1, and also this is the this is master. Also, also you can understand it as a master position. And this is our slave axis position of segment 1. And also others is 1 by 1 to set. Other segments 1 by 1 to set. So here so in my program, my setting is just like this. Three parts. First line 0 0, and the second line 2000 and 2000, and then the third line 5000 and 5000. And the other setting is also the same. We just change first at the beginning we use this table. We use this table to set, and now we are use this remove instruction to set the parameters. Okay. This all is not different. In the first segment, our master plus and slave plus will increase to 2000, and then they will increase to 5000. And they will stop together. Now let's change the value. Here I set master plus master plus 2. Here I set to 1000. 2000. Slave plus 2, and here master plus 3, set 500, and third, so left plus 3. Here I set to 0. Let me increase the speed. It's too slow. This is a master, and this is slave. Oh, it's too fast. This is 5,000. So our master plus and slave plus will run just like this. This curve. Let's see it again. Okay, and these two values. It will perform just like this curve. So in this way, we can also use the move instruction to draw our E-cam curve. Where can we set cap and location? if you want to set the cam curve without by table, by filling the parameters to table, you click here. Here in project manager, and extended function. Here we have a electrical cam table, and here we can build one and click double to draw the curve. Here, data setting, and here we can set the selector one by one. If you don't want to use a table to set, then you can use demove to write the value to some function address. More detail, you can see our menus here, where we have function address introduce and how to set here. Master axis is we need to set as constants. Then we can change it without downloading. For example, use no, we can't. We change the parameters, then we need to download the program again. No, I think. Now using demove for income curve, where to set those parameters such as Alright, I will contact you later after meeting, after training. So also, if you have some problem, you can also write your problem to our form. And now I need to continue because the training is a little long. We have already used 1 hour. Now we see our last part. Use E-CAM TPX instruction to draw E-CAM curves. This instruction, we can use this instruction to create flying soft E-CAM and rotary soft E-CAM. These two functions we need to these two E-CAM we need to use E-CAM TPX instruction to get first flying soft. program. This part is just like we see this part. Here we have the most different is we need to use this instruction and for some parameters. Let's see it in the menu. Here we have 1, 2, 3, 4. We have 4 parameters in this instruction. And then the most important part is D0. Here we have it's our function address table. Here, this is our flying soft parameters table. We need to set the plus of our main axis and the kef types. D14 here. We set 101. And in the beginning here we have already introduced. $101 means here E-ACM this instruction. Here the second parameters is the type of our electrical cam, and 1001 is this type. And then the third set parameters is our E-ACM table function address. Here I used D1000. And the last parameter is the output result. I store the output result to D20 from D20. And here we can see our curve. Our self axis will increase from 0 to 2000 and then reduce from 2000 to 0. And our master axis went from will run 500,000 plus. Because here I set this 500, 5,000. 5,000 is our master plus, and the 2,000 is our slave axis plus. And also here we have other parameters setting. For details, please view our manuals. Here I have no time more to introduce them one by one. Here we need to create our E-CAM curve first. Close this one, close M2 to write these parameters such as master plus, slave plus, and then the curve types, and also these other parameters to our function address. And then write this parameter first, and then we need to enable this instruction. Close. And now we will get our E-CAM curve. So here we can run our E-CAM curve. If we don't set these two steps, we will have no E-CAM curve. So this instruction doesn't work. We must have E-CAM curve first, then we can use this D-CAM instruction. Here, this is our master plus. This is our slave plus. Okay, look at our curve. We can see our master. Here we just draw one cycle, and in fact our master axis will run all the time, and our slave axis will run as this curve. This is just one cycle. It will run by cycle, one by one. So it will increase to 2000 and then reduce to 0. And keep decrease keep increase to 1000 and then reduce to 0 and so on the time. So it will have this effect. This one master axis contains going, constant going, and our slave axis do the same action all the time. And this is our and this is our rotary saw curve. For the just one is our flying saw, and this is our rotary saw. This setting is just like flying saw. We also need to use this this instruction. Here we have many curves. I have already write 5 curves before. And each one is the steps is almost the same. First, we need to write parameters to this function address, and then we need to run this instruction. Here D100 is my function address. So here we can see my value is right from D100 and so on and so on. It depends on this parameter. Okay, and after we get this we get E-ACM curve by this instruction, then we can use D-ACM instruction to output our class. The difference between rotary saw and the flying saw is just the curve. The curve is different. Because they have different action. This one, after curve the board, he needs to return to the first place. So we can see in my first program, my slave axis is run like this one. So it will first run like this, and then here run like this, and then return to 0. Return to 0 like this. From here to here, and back to here. just like this GIF. Okay, and this is the three-way to draw our E-ACM curves. And this is the topic. Our today's topic is finished. Thank you for all you attending this training. Thank you very much. And later I will send you the form. You can fill in your name, company, email, and your questions you want to ask in the form, and I will reply to you as soon as possible. Thank you, Dylan. I will show you the link later for the form. Okay, goodbye. Thank you very much. Expanding to our next training.